Bug juice will vanish until the end of time. Bug juice was, at that point, an extremely huge star before it expanded into a red supermonster. These kinds of stars, for the most part, have a lot more limited life expectancies than our Sun, for instance, which has proactively been around for 4.5 billion years and is expected to sparkle joyfully for another 4.5 billion years. Since we discovered that Betelgeuse is a red supermonster star toward the finish of its life, stargazers and space fans all around the world have been hanging tight for this once-in-a-century occasion. Seeing a cosmic explosion live is a rare occurrence, and it is far-fetched that we will see it. There are various assessments about when Betelgeuse will detonate. The fervor was at that point perfect in 2019 when the red giant star showed an observable diminishing in its splendor. Not exclusively were worldwide specialists and star scientists in a commotion, but the press was also loaded with reports. A few papers revealed signs of the approaching cosmic explosion, and abruptly all eyes moved in the direction of the heavenly body of Orion. Then came the official statements from the main Betelgeuse specialists, who were of the opinion that Betelgeuse would become more splendid instead of dimmer prior to the final end. The analysts were proven right. The oddities in Betelgeuse's dimness went on into 2020 and then went down in the history of stargazing as the Great Dimming in February 2020. Insect Juice's splendor arrived at a record-breaking low. After escalated examination, it was determined that the darkening was caused by a massive discharge of hot gas from the surface of Betelgeuse. The gas cooled, forming a thick rug of residue particles that obstructed the star's light for a long time, causing the noticed lessening in splendor. In 2023, the stargazers unexpectedly noted an increase in brilliance, and again the inquiry emerged with respect to whether this startling change could be a sign that we would soon see the cosmic explosion. The space experts waved it off. By far, most of the specialists concurred that the sudden half-increase in brilliance doesn't indicate an unavoidable blast but is a sort of eventual outcome of the Great Dimming from 2019 to 2020. The huge measure of residue and gas catapulted during the darkening had disturbed the normal brilliance patterns of Betelgeuse. Detailed examinations have shown that the peculiarity occurred within a long-realized multi-year cycle during which Betelgeuse lights up dramatically without being related to an impending blast. The 2020 event abbreviated the normal multi-year cycle to around 200 days. This shortening meant Scarab Juice's increase in splendor not only happened earlier but was also more intense than usual. Dying stars are both a show and a fortunate turn of events. I bet you didn't know that our bodies and our Earth are produced from the elements of dying stars. Notwithstanding the history of our universe, specialists have also recreated the ways in which matter and elements were formed. This uncovered that the first stars and their blasts played a significant role in the development of matter. At first, the universe was wealthy in light components. The primary stars were, therefore, also very light supergiants with an extremely short life expectancy. Within this limited time frame, these giant stars converted hydrogen into helium through atomic fusion, delivering huge amounts of energy, which made the stars shine. Eventually, when the inventory of hydrogen ran out, they fused helium into heavier components, such as carbon and oxygen. These processes ultimately led to huge cosmic explosion blasts that dispersed the heavy components into space, contributing to the development of new generations of stars. As these events continued, new generations of stars, planets, and finally us with our bodies were formed. The oxygen on our planet, the water, and the fertile soil on which we live were formed. Up until now, massive stars continue to spread their components throughout the galaxy and the entire universe at the end of their lives. When Scarab Juice detonates, millions of tons of material, residue, and gases are blown throughout the galaxy. New stars and planets are then formed from these components in other places. So, when Scarab Juice begins its last journey, it won't completely die. Huge pieces of its mass will be reused, and a neutron occasion in the history of science. Star or a black hole will remain after its end. Regardless of these legacies, insect juice will no longer be visible to us. Nearly every individual who is interested in cosmology and space or heavenly bodies knows the star as a significant piece of the heavenly body Orion, the mythical hunter and competitor. With its distinctive sword, Orion is perhaps one of the most popular constellations in the night sky. Betelgeuse, in Orion's shoulder, has been a guiding star and the focus of legends and myths for millennia. When it is gone, an era will vanish with it, and the constellation of Orion will no longer be the same. Only those who are eccentric or believe in the old legends might think that this will have any cultural effect on our planet. Even after the cosmic explosion blast of Betelgeuse, our globe will probably continue to turn as usual. For our science, the ongoing dramatic changes on the surface of creepy-crawly juice and the significant insights that follow are remarkable. Seeing the last stages of the life of a massive star like Betelgeuse is a unique opportunity. Recently, advanced technologies have allowed scientists to observe some supernovae in distant galaxies, but here in our own Milky Way, only 650 light-years from us, this event is of much greater interest to science. So, Betelgeuse's fate is both a show and a stroke of luck. Simultaneously, we will see it with the naked eye. One thing is already certain. Betelgeuse's dramatic finale will be visible to the naked eye from Earth. This offers an extraordinary opportunity to experience the powerful explosion up close. The blast can't be that far away because Betelgeuse has already spent its hydrogen supply. When the hydrogen in its core ran out, the star began to fuse helium into heavier components like carbon and oxygen. These fusion processes released massive amounts of energy millions of years ago, which kept the star stable and made it shine. Over time, the fusion processes became increasingly inefficient. Eventually, layers of different components formed in Betelgeuse. Helium fused in the core to form carbon and oxygen while hydrogen was still fusing in the outer layers. The fusion of heavier components gradually produces less and less energy, and the core will ultimately collapse. The final collapse of the Betelgeuse core is caused by gravitational force, which compresses the matter in the core so much that the electrons are driven into the atomic nuclei. This will lead to a sudden increase in pressure and temperature, causing the core to be destroyed in a massive explosion, which we then see as a cosmic explosion. During the blast, enormous amounts of energy are released, propelling the outer layers of the star into space at incredible speeds. These layers contain countless heavy components that were made by the fusion processes inside the star. These components are scattered into space and contribute to the formation of new stars and planets. When Betelgeuse goes supernova, the event will shine so brightly that we will be able to see it without trying to hide. For a few seconds, it will be like a brilliant flash. Then the remnants of the blast will continue to shine brightly for a few weeks to months. Betelgeuse will become one of the brightest objects in the night sky. The supernova will likely shine as brightly as the full moon for several weeks. You're probably wondering when this will happen. Well, the final blast should be visible by a sudden increase in brilliance within a few days. Betelgeuse will increase in brilliance and then, at that point, detonate. So if you regularly look towards Orion and a star shines brightly there, it could soon be time. Researchers say that the finale could come tomorrow or maybe not for another 100,000 years. The first supernova observed on Earth, Kepler's supernova, was a rare event, and scientists have recently become aware of this phenomenon in our own galaxy. It is estimated that a star detonates every few decades, yet we don't see many supernovae. The last supernova visible and documented from Earth was SN 1987A in the Large Magellanic Cloud, a small neighboring galaxy of the Milky Way. This supernova was discovered on February 24, 1987, and provided astronomers with a valuable opportunity to study the physical processes and aftermath of a supernova explosion. Even further back in history, there was SN 164, also known as Kepler's supernova, in 1604. The renowned astronomer observed the apparent birth of a new celestial body in the constellation of the Serpent Carrier. This supernova was so brilliant that it was visible in the daytime sky for several weeks. Kepler was astonished to note in his journal that a star had been born that shone nearly as brightly as the moon. Betelgeuse's supernova will not only be a stunning celestial event but also a unique,